This conference will now be recorded.
Hello, everybody. Jordan Girth here from the National Weather Service Office of Observations. Thank you for joining us for the Satellite Book Club Seminar Series. This is session number 44. We're glad to be joined today by Eric Stevens, the Fire Weather Program Manager at the Alaska Interagency Coordination Center, or AICC. Facilitator is Linda Gilbert, lead meteorologist at the Weather Forecast Office in Marquette, Michigan. And the presentation title today is Changes in Latitudes and Changes in Altitudes. An Alaska meteorologist forecasts fire weather in Southern California. So I know Eric's got a great presentation planned for us today. Just a few reminders before we get started that we are recording this session. So if your colleagues aren't able to join us due to weather or shift work, they can catch this online later. We'll have an opportunity for Q&A after the presentation. The best way to get your question asked is entered into the chat and we'll field them that way. But if you have a long question and you want to verbalize it, just indicate that and we'll pass to you, let you ask the question. Always looking for future presenters. So if you have an application to share with your colleagues in the field, please get in touch with us. We'd love to have you. And if you're looking for training materials, Brian Mott at the Office of the Chief Learning Officer has information and can field your questions regarding that. They can also create training materials that may be unavailable. Just like to thank the Tower S team, particularly Kashad Bowman, Lee Byerly, Office of the Chief Learning Officer, Gozar and JPS's program. We couldn't do it without them. Without further ado, I'd like to introduce Eric Stevens, who was born and raised in North Dakota and moved to Alaska in 1993 for nicer winters. We just talked about that right before we started today. He has served as a forecaster and science officer with the National Weather Service, a science liaison between the Weather Service and University of Alaska, and now the Fire Weather Program Manager for Alaska. From September 2020 to January 2021, Eric was detailed to SoCal, as they call it, to provide meteorological support during their record-setting season. Eric, welcome.
Thank you very much, Jordan. And it's a pleasure to be here, and thank you all for the opportunity to present. And so we will move on to the next slide. You know, after that introduction, I should mention that Jordan and I go back to the Satellite Proving Ground days, and Jordan had a big hand in developing what I think is the coolest logo ever, because Pacific region and Alaska region are outside the conterminous US. And we, even though you might think are different places, have some things in common. But Jordan and I did have to have a meeting because I advocated this version where you got to have sunglasses on the bear. Jordan shot me down, but now it's my presentation. So there you go. Shirts will be available. Just send me an email. And well, we already went through that. Okay, first, a little bit of a description of who does what in fire weather. Where does the Weather Service fit in, and where does not Weather Service fit in? So the Weather Service is always on the job and is looking for all kinds of trouble. But the Weather Service is not staffed to deliver customized forecasts and customized live briefings on demand for every potential user group out there. It simply can't do it. The wildfire community, in an attempt to get this customized, very specific support and decision support from a forecaster unit, they came up with the Predictive Services Units, PSUs, to provide forecasts and analysis of course, the weather, and then the moisture content and burnability of the fuels, and that's related to the weather, and then what the fires will do, how will they behave on a given day, that's also weather related. But the PSUs have weather meteorologists and then fuel analysts and fire behavior analysts, or FBANs. And there are 11 geographic area coordination centers, or GACs. Everything's an acronym. And so the GAC meteorologist focuses just on the weather parameters relevant to fire weather. And then you have to communicate this info to land managers and the fire crews. It's all about decision support. Those people need to use weather to make a decision. They're not meteorologists though, so you don't need to, it doesn't help to impress people with big baroclinic words. And in Alaska and in my experience in Southern California, the work is very front loaded in the morning. You're in Southern California, when the day started, I would get there at 5, and you have a lot of briefings. Things kind of slow down at about 11, depending on the weather. And the weather parameters we care about: wind speed, direction, relative humidity, not dew point, temperature, and the impact of the terrain on everything. You know, we're a big, happy country, and happily, so far, the entire country doesn't really burn at one time. In Alaska 2 years ago, it was a big season. 2.5 million acres went up in smoke, and lots of crews and managers, professionals came up from the lower 48 to help Alaska. Last year, Alaska failed to burn, and so a lot of people went down south. That's the way it should work, and it does. So California was where the action was in 2020. They had over 4.2 million acres burned. That's the highest acreage total ever recorded yet again. When I first arrived in September in Riverside, California, one of the managers there mentioned, he was kind of shaking his head, and he says, you know, these last 15, 20 years, you know, we have a year that is unprecedented, and we think, wow, I'm glad that'll never happen again. And then 2 or 3 years later, it's worse. And then 2 or 3 years later, it's worse again. In 2020, August complex alone was over 1 million acres, and occasional extreme wildfire behavior, including plume-dominated fire behavior, as per this picture here, occurred. So why did it happen? And these, anyway, the top 20 largest fires, 5 of the top 6 were this year. Here's just a little bit of a terrain map of the central and southern California area on the left, and then on the right are the burn scars in those little black outlines. It's interesting to see that the San Joaquin Valley, that's where the entire industrial capacity for mining asbestos comes out. So no burn scars there. Well, actually, there's too much agriculture. Humidity is always high there, it seems. And then further out here in the deserts, certainly it gets hot and windy, very dry there, but there ain't much to burn. So the ground can't carry fuel. The classic burn scars, these are the Santa Ana wind areas right along and just inland of the population corridor from Los Angeles down to San Diego. So what happened in 2020? Well, 2020 began, as usual, with some rain that ended in April, and that's normal. The rainy season there in Southern California is in the winter, it tapers off in the spring. They got the rain in 2020, but not as much as normal, but they did get a fair chunk. Then dry weather continued, and in mid-August, they were hot and dry. That's normal, but then on August 15th, a dry lightning event started over 500 individual fires. The Weather Service in San Francisco described it as insane, again, staying away from jargon terms. And then after those fires were started, the dry weather continued. That's climatologically normal, and occasional bouts of heat. And so those fires just through the rest of September and into October were just loose on the ground. The season-ending rains that typically descend southward along the west coast in the fall, they were delayed because it was a strong La Nina phase of ENSO. La Nina peaked in November timeframe, and that's not terribly unusual, but not every year has a peaking La Nina right when you want your season-ending rains in Southern California. And as the baroclinic season becomes more meaningful, the Santa Ana wind events become more common. And if you haven't had any rain and you get into Santa Ana season, that's a bad combo, especially when fires are already on the ground. And finally, an atmospheric river event ended things in 2021. Here's Riverside, California, just a way to demonstrate that it was a drier than normal year, but they did get, this is accumulated precip through the year. The green trace is the 2020 year. Brown is normal. So you can see that we got the rain at the normal time of year, but it stopped at about 5.5 inches instead of getting up to around 9. Okay, well, you get what you get. And then when normal rain starts to pick up again in the fall and into the winter, we just got teased there. It wasn't until the end of the year that things began to pick up. And looking at accumulated cooling degree days as an expression of temperature, again, through the year, 2020 is in green, and the blue curve is the highest ever observed. So we're kind of hugging that all year, well warmer than the brown normal temperature by accumulating cooling degree days there. So it was a dry year and a warm year. And La Nina phase here, October, November, December, maxing out in the region 3.4 there. So that's too bad because of the teleconnections favoring dry fall and winter weather there. Now that lightning event that happened around August 15th was somewhat unusual because we can see here that the coastal areas of California just don't that's not lightning headquarters. So when they get a big event there, it is meaningful. And it only took one brief assignment to Southern California for me to start displaying maps of the United States of America that don't show Alaska. And dry lightning, just a dry higher base thunderstorm on the left. When you have lightning at the ground but not much rain at the ground, that's how you start a fire, in contrast to the guy on the right. And there was a severe thunderstorm warning. This is from August 16th there at the San Francisco Monterey forecast office. That doesn't happen every day. And on the right are some of the fires that began with that lightning outbreak, very widespread. Now here is how a Santa Ana event, so we're getting into late Santa Ana event proceeds, getting into late October, so baroclinic forcing is becoming more meaningful here. And watch over these few days as a trough aloft, we're looking at 500 millibar analyses here, a trough comes in from the northwest and then digs down into the Great Basin before cutting off there in southern New Mexico. This is the classic inside slider mechanism aloft, and the trough is digging too far inland to access maritime moisture there, and so it's a dry pattern, and that's classic there for Santa Ana winds. So you have that pattern aloft we just looked at. Down at the surface, there's actually high pressure over the Great Basin with some cold air at the low levels. So it's a katabatic offshore wind, even though right at the coastline you get some compressional warming, and some of the warmest temperatures can occur during Santa Ana events. The wind is modified by terrain, gap winds, downslope winds, maybe even breaking mountain wave mechanisms could be involved. And humidity, amazingly, in the single digits, it just doesn't recover. And winds can be very strong. Here's the high or red flag warnings issued during one Santa Ana event, again, covering where a lot of people live. Now this is a satellite book club, so satellite imagery. And Bill Line over at the Satellite Liaison blog always puts out some great stuff. And this was an experience that I had to use the miraculous GOES-R imagery operationally at a latitude where it's quite appropriate. And during Santa Ana wind events, those are offshore events and they're very dry, so you don't have any of those pesky clouds in the way. So you can see right down to the ground. And here we're looking at some thermal imagery, shortwave IR, and we can see the fires advancing and then a wind shift carrying the advance along. We'll add in visible, and then the thermal imagery becomes the yellow stuff there, again showing the impact of the wind on the progression of the fires. And the smoke here begins to show up again in the visible spectrum. Can't see that in the IR. And then, of course, we've got some day-night band to look at, and this occurred over the course of a couple of days there. And what's fun is in northern Washington, there we see the fires overnight now evident, and watch them progressing. Again, a level of detail that you can get from the polar side that is just not there in the geostationary birds, even though geostationary gives that frequent temporal coverage. And here's another day-night band versus just geostationary thermal, again demonstrating the resolution difference. And when I look at this kind of thing too, you think, well, in Alaska the difference is even larger because the geostationary view will have more pixel broadening and no parallax problems though if you're seeing the ground, I guess. Okay, and here is a beautiful loop from Colorado State there, the geocolor overnight, and then, or I'm sorry, the geocolor during the day, and getting the differencing overnight there. Seeing the offshore flow, you can see the smoke from fires being blown offshore, and also the wave propagating out over the water there. That's just beautiful to see. Also, plenty of fires in the Sierra there, and air quality, as we will look at in a bit, is just always a nightmare there. It sure seemed that way in the San Joaquin Valley. Here's looking at some thermal imagery, and this was fun because look right there, you can see a new fire come into existence there. As the day progresses, the land is heating up, see it getting darker with the sunshine, and of course all kinds of fire action there in the Sierra. Again, with a picture every few minutes, and with, even when we're not in rapid scan operations, and with clear skies, you can see down to the ground. This is a very good surveillance tool for real-time operations. Now, I've been wondering about mountain wave mechanisms during the strong Santa Ana wind events. Just wondering if there's an applicability of the new CAPS profiles from the polar orbiter birds from SNPP and NOAA 20. And we need to find a critical layer, temperature inversion at the elevation of the terrain crest and also a local wind speed maxima at that elevation. New caps might be suitable for finding these critical layers because Santa Ana winds are, commonly include the clear skies, as we just saw, and new caps has a problem getting through clouds sometimes. The temperature inversion we're trying to find is elevated, so you're not messing with the boundary layer, where again, new caps can have some challenges with fine fidelity there. And there are actual RAOBs at Vandenberg Air Force Base and the San Diego Weather Service office to verify that. I kind of have a pet thought in the back of my head there. They've got a new forecaster coming into South Ops, and she's pretty interested in maybe collaborating with me on a project about this. And who knows, maybe we can put a blog article together if we find anything. But that's something for the future that I want to see if the satellite tools can be exploited in new ways. And if so, could it be helpful for us in Alaska in our summer seasons? We do get wind events, although it's the summertime. You know, June and July is our big fire season, less baroclinic forcing then. But I mean, there's always some. Moving on to air quality here, this AirNow website was pretty darn handy. And coming from Alaska, look at all those little circles. Those are real ground truth air quality observations. We've got like 5 in the whole state of Alaska. So you're thick with observations, and even you can zoom in. Let's go to Elsinore for fans of Hamlet, and we can see that their PM 10 really got terrible, and it was due to the changing winds with the onset of a Santa Ana wind event. That can do everything, just blow the smoke in or out of a given area. And you know what? These GACs where the forecasters work, they are called coordination centers because there are so many players in wildland fire, from state agencies like CAL FIRE and federal agencies. And then there in California, the phone rings and I pick it up and it's Pacific Gas and Electric talking about the upcoming wind event because they want to know about maybe cutting power. And it's their meteorologist that's talking to me. They have air quality meteorologists, the San Joaquin Air District and the California Air Resources Board. We have conference calls and those people know what they're doing. You can use the OMP sensor, which I have not used a whole lot, but took a peek at it a few times. And the air quality professionals at San Joaquin Air District and the Air Resources Board, they would call the South Ops meteorologist to do some general synoptic coordination and discussion. But when it came to forecasting actual like PM 2.5 categories for air pollution, they had the ball, but satellite imagery there was relevant as well. Well, that is all that I had there, and I will be happy to take any questions there if there was anything unclear or tantalizing. And again, thank you all for the opportunity to speak to the group.
That was fantastic. Thank you so much, Eric. Very engrossing presentation. So yeah, as Eric said, we are certainly wanting you to stay on for additional discussion. And if you have any questions, absolutely go ahead and put them into the chat right now. So at this point here, as you can see up on the screen, a week from today, on Thursday, April 15th at noon Eastern Time, David Zaff, the Science and Operations Officer from the WFO in Buffalo, will discuss an application of microwave imagery for detection of atmospheric rivers. So definitely come back and join us again next week for that very interesting presentation. And absolutely reach out to the Tower S team if you do have any questions for the SBC or about the Satellite Book Club or any sort of configuration of satellite products. And then more information will follow in an email from the Tower S team. So with that, we'll go ahead and jump right into the questions. And make sure that you share any feedback that you have on the session or the SBC in general in a short survey that will be provided. Okay, so we've already got at least one question here. So I'll go ahead and start with that one. Any account for how many fires were started by arson?
Well, that's a good question, and I don't have a direct answer for California's statistics in 2020 regarding arson. It does seem that the ratio of human-caused to naturally caused fires, at least in Alaska, is about even, 1-to-1, although the vast number of acres consumed by fires are consumed by the fires that were started by lightning. Because in Alaska, they don't fight fires that are out in the middle of nowhere. Why spend money doing that? Fire's a natural process, but they do fight fires near town, and the fires that happen near town tended to be started by people. Now in California, I did hear some stories though this year that it was such a, I wouldn't say panic, but it was a public concern with the fires out there. And there were some stories, I think, in Oregon about, I guess you'd have to call it vigilantes, but people convinced that there was arson being a cause of these fires, and so they set up roadblocks and to make sure everybody's good. Wow, that'd be weird. I see a comment from Scott Lindstrom there, I believe, yes, referencing a blog post on the Wisconsin satellite blog there, and I had a slide of a screenshot from that exact blog post, Scott, that I cut from this presentation for the sake of time. But yes, you mentioned the new caps there, and I would like to build upon that. And here's Tim Schmidt in the chat. Might more frequent than hourly land surface temperatures be useful for monitoring the extent of heating associated with Santa Ana winds? Huh. I don't know, Tim. That's, I'm unfamiliar with that exact, I don't know. I'll have to punt on that. But you know what? Using the satellite for where this, I think, is going is fuel burnability. And NDVI has been used forever. And but temperature, if we could get that, you use just any individual moments shortwave IR for some of that. And here's Jarell Torres. Hello, Jarell. I assume you have used the VIIRS fire temperature RGB and the VIIRS dayland cloud fire RGB to observe the fire hotspots, infer fire intensity, burn scars, and fire smoke. Yes, RGBs are available online, real Earth, and can be accessed in AWIPS for Alaska and CONUS users. Yes, indeed, we do use those products, and in Alaska, there's a direct broadcast reception at the University of Alaska Fairbanks where they grab the polar data and generate those RGBs. So that's definitely very usable here. I think what I would like is some more, okay, no knocking on anyone, but when a non-meteorologist, one of the fire managers, they say, hey, where can I look at that imagery? Sometimes a website that's more, it demands more of the user for picking channels and time steps and things. That's hard. People aren't going to do that. So I'm hoping to get those. You know what would be awesome is those RGBs on a simple click it and get it a website for use by the non-meteorological wildland fire community, because there's some interest in these pictures when I give briefings. And I got to confess that last year I had to work from home, and I'm home right now. And last year the internet bandwidth in my house was sad. It was party like it's 1999 dial-up days, and I couldn't use the full bandwidth imagery. I couldn't use it in briefings. Luckily, we had no season last year, so we got away with it. But this year, you bet, we're going to plug that imagery, and from we're going to try to make the most of GOES 17 as well. And Julie Price says, did you find some differences, similarities, and surprises in satellite data applications, Alaska versus California? Well, you know what? One thing that I noticed was in the meteorological culture that I was exposed to during my time in Southern California does not think about polar imagery a lot for surveillance. They are very geostationary centered. And I suppose that is appropriate given the latitude. The day-night band did get some use and reference every once in a while. And again, I'm looking for use of the new caps coming from the Alaska perspective, where we really make our money on polar orbiter imagery. It was interesting to go down south. I guess I would like to shake the cage a little more for the polar imagery, because there are times when it gives you that added spatial detail that you just can't get. Evan Polster asks, How long were you stationed at Riverside in Southern California? When will you be returning to the Alaska GAC? Well, I went down in September and came back on January 6th, which was a fun day. And so that was a long assignment, and they still have one job vacancy there. If you are interested in doing fire weather meteorology and being a communicator to all kinds of people who are going to take what you say and decide to send 50 engines from Phoenix to Los Angeles or something, the job is there, and they need somebody. Okay, and then Michael Jamalowski says, which GOES-R data-derived products do you consider most valuable for fire weather forecasting? Well, I tell you what, just like Jarrell mentioned above, some of those RGBs are great. Getting the veggie band in there is great for finding burn scars. Having some visible spectrum wavelengths lets you see the smoke really well, and getting some of the longer wavelengths gets thermal active fires all on one screen. And so, well, I just described the Dayland Cloud Fire product, I guess. So I think those imagery products are the most important. Now, data derived, I guess I'm gonna punt on that one. Ian Zello says, a number of people in groups talk about the fire problem, but with your experience in two very different regions, what does the fire problem mean to you? Oh boy, that is a big one. And I'll answer that first from a meteorological point of view. I'm really concerned that now that I'm getting old and curmudgeonly, and I've got, you know, almost 30 years doing weather in Alaska, and I have an experience base, and experience gets under your skin maybe when you don't notice it and you don't know why. You know what you know, but you look at a weather map and you think, you know, this doesn't feel right, or the forecast, well, you're gonna have to change it. And you maybe don't immediately know why, but you just have a feeling. And then you look into it and you go, oh yeah, that's why there's that feeling. Well, I'm concerned that if the, you know, daily weather is superimposed upon climate, and if climate changes out from under us, our weather will have to change with it. And my experience is based on a previous climate. When I first came to Alaska in the 90s, there was this thing called sea ice in the Arctic Ocean in October. And now in October, you just don't see that along the Alaska coast of the Arctic Ocean. And that changes our sensible weather. And so that's a big problem, I think. Now, so that's climate change. Also, there was a discussion about the human nature danger interface. That's not a real term, but that's how I heard it. Like with hurricanes, if there's a hurricane that wipes out a town on a coastline and then the government goes in and builds new homes, everyone will say, well, why'd you do that? You're only encouraging people to get in trouble again for the next hurricane. The same kind of discussion is being brought up in the world of fire as people build out in, you know, my own house. I'm on a 2-acre lot here in the woods. So, you know, I'm part of the problem, I guess, and our house it's mostly defensible space, but I think that's one of the biggest problems is going to be keeping humans and fire each in their own lanes so there aren't problems. Wow, what a great variety of questions.
Absolutely, and definitely we'll keep this conversation going here if anybody has any additional questions. Let's see, I actually did have a question here for you, Eric. So you talked about new caps. What about GLM? Because you talked about lightning and those triggering fires. So how much did you or do you incorporate GLM into your fire weather ops?
You know what, the GLM in Alaska, because of the high latitude there, we do not get GLM imagery, so I have no experience using it. And I was so looking forward to, oh, we're going to look at the GLM. Well, they had that big lightning event in August, and then after that, man, I think they had single-digit number of lightning strikes in our area of responsibility after when I was there. So it wasn't relevant to our forecast issues of the day. But I did look at GLM imagery, you know, just for the whole country, just to play around with it. But no, I didn't use it for this specific job.
Okay, great, thank you. All right, we'll give it just another minute or two, see if we've got any other questions that are going to be coming in here. This has been some excellent discussion, so definitely keep it going here if anybody has any additional questions.
Oh, this is Jordan. I'll have just a question for Eric, given his previous role as the satellite liaison. But, you know, maybe for people, I know me, you, a lot of people on this call, probably very heavy satellite data users. And you presented a few examples of the shortwave IR, but you also mentioned that there were other people that needed this data. Maybe could you talk a little bit about what you have learned about the best satellite products for finding fires, and what do you think we should provide, if anything, to weather interested parties that are not necessarily containing a meteorology background?
Right. You know, giving people what they ask for sometimes is a little frustrating. I just put out on April 1st here the seasonal forecast for fire weather for Alaska going out to the end of August. And I am terribly cynical about the skills of those forecasts. And I explain that. They say, don't even bother to keep your receipt, and you're not going to get your money back on this thing. It's worthless. And they still want it every year. They want to hear what you think, even if it's just a little bit, they want that. And when I show satellite imagery in briefings, even to a non-meteorologist, that imagery often looks really cool, and they want to look at it more. So I guess I would answer your question, Jordan, by saying I think what I mentioned earlier about a website where the imagery products are available in a pretty easily accessible, digestible way. You know what? The GOES 1617 image viewer website that NOAA has is like that. I would love to see the fire temperature RGB and the dayland cloud fire RGB. Put those RGBs on that GOES 1617 website. That's a really user-friendly website. You just click on the resolution size you want, or if you want a movie or not, it's easy to download an image or a movie loop from there. User-friendly for the non-meteorologist, I think will help. It's going to be increasingly wanted, I think, too. South Ops has a website. In Alaska, we have a website too, but in South Ops, I discovered one day when I picked up my phone, their website dynamically adapts to mobile users. People are using phones and iPads out in the field now, and so they might be able to get at imagery out in the field themselves. In the future, they'll want to be able to get at it, and if we can give it to them in a useful, user-friendly way, and then that's where the liaison community comes in, I guess, too, or the GAC meteorologist community to train people on, well, this is what you're looking at. These are the things that are important out of all these goofy colors. Here's what we want you to know. And then we should always respect, too, that other professionals might see something in imagery that I, as a meteorologist, don't notice, but they might notice something in a landform issue that's important for them. And so they're intelligent folks too, who can find their way to get their data.
All right, we do have some additional discussion. We actually have a couple more questions that just came in, as well as some links that were shared in there. So thank you very much for those folks providing those resources. So the next question, what percentage of your data products I think he is meaning to say here, are you using, are coming from websites versus desktop tools? Does your network bandwidth from your home prevent you from accessing certain data?
Well, last year, the bandwidth was definitely a hindrance, but right before I went down to South Ops in September, we got internet in my house is 40 times faster than it used to be. So this season, this fire season, I think it's going to be, all pixels go. And but last year, getting back to Evan's first question there, what percentage of your data products are using from websites versus desktop tools? And in the Weather Service, when I was in the Weather Service, we had AWIPS to look at everything, but then the internet showed up, and AWIPS often was a step behind. You could only get the quick scatterometry ocean wind data for a while there on the internet, and it wasn't in AWIPS, and we loved that stuff. And so I think if people can't find it, the first choice is AWIPS or your dedicated software hardware that you have professionally provided for you. But if you can't find it there, go on the interweb to get it. And there's a lot of stuff that is on the web. And I think in the fire community, different from the Weather Service, the meteorologists rely on internet-based things a lot. In fact, Alaska, this was a real advantage. They threw some money around and hired John Horrell's group in Utah out of MesoWest to make the Alaska Fire and Fuels interface. It's internet-based, and wow, we use that. That's our primary tool. And it's not even official AWIPS. But that's more for looking at fuels data and temperature data in a statistical sense. Looking at weather like models and satellite imagery, radar returns, that's best done on our AWIPS system, or what's coming, the GAC meteorologist will be getting an updated version of AWIPS, as Evan knows, in the future.
All right, great, thank you. And then it looks like we have a comment here. Non-NWS stakeholders within California do use satellite-derived fire products. The biggest hurdle is that data needs to be GIS compliant formats, for example, not NetCDF.
Yes, and I would reiterate that too, that in Alaska, my experience is that it's nice to operate in GIS for the non-meteorological community. Happily, Gina at UAF, they crank out their direct broadcast products, including as GeoTIFFs, which are friendly for GIS, and the fire service here does use that.
All right, great. And give it just another minute or two, see if there are any last minute questions or discussion, comment points that come in here. But this has been outstanding. Thank you so much, Eric, for your presentation and spending the time to chat about your experiences and all of this. So I'm not seeing anything else come in here. So I'm just gonna go ahead and turn it back over to Jordan for the final remarks here. Thank you so much.
All right, and thank you so much, Linda, for moderating, and Eric, great job on that presentation, very engaging, and enjoyed it very much, especially bringing your Alaska perspective into Southern California with such a substantial fire weather season that they had last year. So thanks again. And thanks to all of you for being out there today. Hope you're staying well, and hope you're starting to enjoy spring if you're not up in Alaska, where apparently winter is clinging on yet this April. As Linda had mentioned, please hope you'll join us on Thursday next week, once again, April 15th, 12 noon Eastern time, our standard time. Dave Zaff, Science Operations Officer, is going to be talking about microwave imagery for atmospheric rivers. And if you have any questions, once again, we have the Tower S team standing by to assist you to get satellite data into your operations. Until then, hope everybody continues to stay well and take care.